Okay, so this is a tutorial to help you solve the problems involving gravity and freefall. I'm going to sketch solutions here and give you the plan, but you'll still need to make a diagram and a variable list and all those things. And remember, my numbers are different than your numbers, so you'll have to account for that as well. So in the first one, you have a bridge, and a rock is thrown upwards, but it won't go upwards forever. It'll come back down. And this is the initial velocity here. So you know the initial velocity. You know the acceleration, of course, is negative 9.81 meters per second squared. You know the time. I give you that. And so the plan is to solve v final equals v0 plus a times t for the final velocity. And of course that'll be negative, which means it's moving downwards. So for part B, it's the same problem. And now what you're trying to find is what will be the position of the rock. So to do this, you've got to figure out delta y. The rock starts here, it goes up and back down, and then at your time, it's somewhere right here. And you've got to find delta y, this distance, delta y. And so the plan for this one, the easiest plan, is probably to use delta y equals v0t plus 1/2 at squared to find delta y. And then remember, you started 80 meters in the air. So if delta y is negative 20 and you start 80 meters in the air, then the position will be 60 meters, the 80 meters plus delta y, which is negative. So you're going to solve this equation for delta y, and you have everything you need there to solve that one. Number 2, a penny falls from rest, which tells you that the initial velocity is 0. It's from a high window. It accelerates downwards because of gravity, so we know the acceleration is going to be negative 9.81 meters per second squared. And it says how much time will pass before the velocity is negative 20. So the final velocity is negative 20 meters per second, and so you will solve v final equals v0 plus at for the time t. The next one is the helicopter problem. This is a helicopter, so it's somewhere up here in the air. Here's the physics helicopter, and it drops a package, and the package falls down to the ground. Okay? And we're asking how long does it take to reach the ground? The thing here is, if the helicopter is 130 meters high, then the distance the package will travel is negative 130 meters. The velocity initial of the package is 0 because it says it is dropped. We know the acceleration, of course, is negative g. That's negative 9.81. And you don't know how long it's going to fall. The easiest way to solve it is to use delta y equals v0t plus 1/2 at squared and solve for t. You will not need to use the quadratic equation, though, because this term is 0. The initial velocity is 0, so you can extract the root directly. You can solve for t. What will be the velocity of this? Well, once you know t, you can say v final equals v0 plus a times t, and you'll know everything there to be able to find the final velocity just before it hits the ground. Now we have a bored physics student who drops a rock off a bridge. It takes 7 seconds for the rock to hit the water. So we have some bridge here. The rock falls. The initial velocity is 0 meters per second because he drops the rock. The acceleration, of course, is negative g because gravity changes the velocity. We know the time is 7.0 seconds, and notice there's only 2 significant figures there. And we do not know the final velocity, so the easiest thing to do to figure out how high the bridge is first to solve delta y equals v0 t plus 1/2 at squared for delta y. And delta y will be how far the rock moves, and it's going to be negative. So whatever that answer is, the height of the bridge is going to be the opposite sign, so it'll be the positive value. So if it falls 20 meters down, then the bridge is 20 meters tall. So that's how you're going to solve number 4. Question number 5 is about an arrow, and it's launched upwards with an initial velocity, and we want to know what's the height after 4.5 seconds. So we're going to launch it from the ground, so that's y equals 0, and the arrow is going to go up, 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 stop, and come back down. And we want to know where is it after 4.5 seconds. So after 4.5 seconds, it's going to be somewhere here. We want to know what is delta y. How far has it gone up? So in this case, we know probably the easiest way to solve this is to say delta y equals v0t plus 1/2 at squared, and we are going to find delta y, how much it's gone up. We know the initial velocity, it's given. We know the time, it's given. And we know the acceleration, of course, is negative g. So we can plug those in and we can find out delta y, how far it goes up. Okay? This one here says, how high should you be if you want to drop a tennis ball and have it hit the ground with a velocity of negative 45 miles per hour? So the first thing you got to figure out is, when it hits the ground, that's the final velocity. So we're going to drop it. So the initial velocity is going to be 0. The final velocity is going to be whatever this is in meters per second. You'll have to do a conversion. Okay? So let's say that's 20 meters per second, and it's negative. And we want to know how high should you be. So that means like delta y is what we're looking for. And of course we know the acceleration is negative g. So the easiest thing to do here is to solve v final squared equals v initial squared plus 2a delta y for delta y. And of course the final velocity, you got to use meters per second, not miles per hour. The initial velocity, again, it's dropped, that's 0. So you're going to solve for delta y. That tells you how far the ball falls, and so the height will be the opposite sign. Okay, this one's a football. It's kicked from the ground. It starts and ends at 0, so it goes up, 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 down, 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 like that. And we want to know how long will it be in the air. So in this case, delta y actually equals 0. It starts and ends at the same height. Velocity initial is plus 25 meters per second. It's different for yours. The acceleration, of course, is negative g. And what we want to do is we want to solve. We do not know the final velocity. We don't know how fast it's going when it gets back down here. So we're going to solve delta y equals v0t plus 1/2 at squared for t. And when we put in 0 here, we'll have 0 equals, I'm going to factor out a t here because both these terms have a t. So I'll have a t times v0 plus 1/2 of at. And you might remember, this is a little bit of algebra, if the product of two expressions equals 0, then either t equals 0, which makes sense, it's on the ground at the beginning, or v0 plus 1/2 of at must equal 0. And so that there gives you an equation you can solve for t and figure out how long it's in the air. Number 8. How long will it take a ball to reach the ground if it is thrown out of a window with an initial velocity? So it's thrown upwards. Okay? So the window is 50 meters above the ground. So this is a pretty darn high skyscraper. And it's thrown upwards. It's going to go up, 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 and then down, 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 all the way to the ground. Okay? So in this case, the initial velocity is positive 20 meters per second. Delta y, it starts here and it ends here. And since my building is 50 meters tall, delta y is negative 50 meters. My acceleration, of course, is negative g. We do not know the final velocity, and we're asking for the time. So in this one, we're going to solve delta y equals v0t plus 1/2 at squared. If I plug in my numbers, I get negative 50 equals 20t. 1/2 of a is negative 4.905 t squared, and you're going to solve this either by graphing it or using the quadratic equation to find the time. Okay? Number 9 is the exact same problem again. So you don't even really need to make a new list or anything. The only difference is the ball is thrown downwards from the window. So in this case, the initial velocity is negative 20 meters per second. So up in this quadratic expression up here, you're going to have a negative 20 there. You're going to resolve it and find the time that the ball takes to reach the ground if it's thrown downwards. And obviously this answer is going to be a lot less time than that answer, than when it was thrown upwards. And the last one, number 10, you're on your own. But that's a quick overview of how to solve the problems in this assignment.